complex numbers question number 1. Z squared plus 2z plus 10 equal to 0. So we can use the quadratic equation. A is equal to 1, B is equal to 2, C is equal to 10. Using the formula minus B plus or minus B squared minus 4AC, everything divided by 2A. So that will give us minus 2 plus or minus 2 squared minus 4 times 1 times 10 divided by 2 times 1. So now minus 2 plus or minus 4 minus 40 divided by 2. That will give the answer minus 2 plus or minus 36 divided by 2. Therefore, the answer for this one, minus 2 plus or minus, I'm going to write 36 multiplied by minus 1. Everything divided by 2. So this answer is going to give us minus 2 plus or minus 6 root minus 1. But in complex numbers, root minus 1 equal to I. That's an imaginary number. Therefore, the final answer, minus 2 plus or minus 6I. This is divided by 2 and divided by 2. So if we divide by both of them by 2, minus 2 over 2 plus or minus 6I over 2. So the final answer is going to be equal to minus 1 plus or minus 3I. That's the first part of the question. The second part, find the modulus and arguments of each root. So the modulus for this one, minus 1 plus 3I. I use the plus 1 first. That will give the answer 1 plus 9, that is equal to root 10. So you can draw the diagram here. This is going to be on minus 1 here and 3 here. So that's going to be on the second quadrant. Therefore, the answer is going to be arc minus 1 plus 3I is equal to arc tan, ACR tan minus 3 over minus 1 and plus 5. So you should get the answer for this equal to arguments of minus 1 plus 3I is equal to 1.89, 3 significant figure. And similarly, if I do the next one, the negative one, minus 1 and minus 3I is still we are going to get root 10, but this time this is going to be on the other quadrant. So that will be minus 1 and minus 3. So that's going to be on this one. Therefore, this answer is going to be arc 1 minus 3i will be equal to simply minus 1.8923 SF. That is the first question answer. The second question, the complex number alpha is given by this one. Write down the complex conjugate for A star. That is a straightforward answer. That is will be equal to minus 2 minus 5i. Then they ask you to find the modular and argument for alpha only, not for the alpha star. Okay, conjugate. They didn't ask for that. So I go straight into the second part of the question. The second part of the question is, I'm going to say first one is given as alpha equal to minus 2 plus 5i. So modulus alpha equal to 2 squared plus 5 squared, and square root, that answer is root 29. Okay, root 29. The third question, they ask you to find alpha plus conjugate of alpha divided by alpha in the form of a plus bi. So if you put the information, that should be minus 2 plus 5i plus minus 2 minus 5i divided by minus 2 plus 5i. So that is equal to minus 2 plus 5i minus 2 minus 5i over minus 2 plus 5i. So you can see this one and that one cancel out. Therefore, minus 4, everything is divided by minus 2 plus 5i. So we can now multiply by the conjugate of the denominator. That will be equal to minus 4 multiplied by minus 2 minus 5i and minus 2 plus 5i multiplied by minus 2 minus 5i. So now, the answer is going to be, if I do that part, that is the top one, that is equal to minus into minus, that will be, if I do that, that is going to be minus 4 or minus 4, that's right, yes, and if you multiply that, that one is going to be minus into minus, that will be plus 8 minus 5i. Not 5i, minus into plus, and again that is going to be equal to plus 20i. So this one now, on the bottom, this is same as if I put that one as A and that one as B, then that one as a B. So that's going to be simply B. That is equal to difference in square. So I can write down A squared minus B squared. So that is simply minus 2 squared plus minus 5i squared. So if you simplify that, that will give you 8 plus 20i over, this is going to be equal to root 29. It's going to be 4 plus root 29. Okay. So the other answer, they want in the form of a plus bi. So the answer is going to be 8 over root 20, not 29, that is simply 29, and plus 20i over 29. So that will be the final answer.